In this video, I'll show you how to calculate a confidence interval for the mean when we assume that the population standard deviation sigma is known. And for this example, we have the amount spent in a department store by 100 customers. We're going to assume that we know the population standard deviation is 20, sample size is 100, so our standard error is 20 divided by the square root of 100. Our sample mean is the average of the 100 amounts, and that comes to 82 in this example. We're going to calculate a 95% confidence interval, which means that alpha is 0.05, and the confidence is 100 times 1 minus 0.05. And then the z critical value, we're going to use the norm.inv function. The first argument is 1 minus alpha over 2. Second argument is the mean, 0. And the third argument is the standard deviation, 1, for a standard normal random variable. That gives us the familiar z critical value of 1.96, which goes with a 95% confidence interval. And then the lower bound of the interval will be sample mean minus 1.96 times the standard error. The upper bound will be 1.96, sorry, sample mean 82 plus 1.96 times the standard error. So the interval is 78.08 up to 85.92. There's another way of calculating this using this function here, the confidence.norm function, which takes 3 arguments. The first one is the alpha level. The second argument is the standard deviation. And the third argument is the sample size. And it uses these to calculate the margin of error, which is the same as the z critical value times the standard error. Okay, 1.96 times the standard error comes to 3.92. So this is just a shortcut way of getting there. And then the confidence interval is the sample mean minus the margin of error up to the sample mean plus the margin of error. Either way, you get the same answer, 78.08 up to 85.92. We're 95% confident that the population mean is in the interval. Okay, what happens if we were to increase alpha, let's say to 0.1? So in other words, we're talking about a lower level of confidence, 90% instead of 95%. With a lower level of confidence, our z critical value is smaller and our interval is narrower. Okay, the reason is we're slightly less confident, and so we can go with a slightly narrower interval because we have less confidence in it. Okay, conversely, if we went with a smaller alpha, increased our confidence, say to 99%, our z critical value goes up, and we're going to have a wider interval. Okay, if we want to be more confident about where the population mean is, we're going to have to widen our interval to reflect that increased level of confidence. Okay, there's another way of finding a confidence interval that kind of bypasses all these formulas. So I recommend using this method first just to kind of come to grips with the formula and the idea. But once you've done that, it's much easier to simply use XLSTAT. So let's do that. So if I go to parametric tests, one sample t-test and z-test. It's going to be the z-test part that we use here. And we're not actually going to do a hypothesis test because we've not reached that point in the course yet. We'll use this simply as a means of finding the confidence interval easily. So we select our data. So it's the numbers for amount spent. We'll put the results in a new sheet. We have a column label at the top of our data selection. We're going to do a z-test, not a t-test. We'll do a t-test shortly, but not in this video. So we'll do a z-test. Under options, we're going to user define the variance. Okay, we're not going to estimate it using the sample, because then we'd be doing a t-test. We're going to do a user-defined variance. And remember, the variance is the square of the standard deviation. So if we're assuming the standard deviation is 20, then we need to type 400 into here, because 20 squared is 400. Make sure the significance level alpha is set at 5%. And then for the output, make sure that confidence interval is checked and detailed results. And then if I OK that, okay, we get our confidence interval right here. Okay, don't worry about all this stuff. This is going to come later when we talk about hypothesis tests. We're only interested in the confidence interval right here, 78.08 up to 85.92. If we want to round it to 2 decimal places. And that matches what we got when we did it by hand.